Hi there, welcome to my YouTube channel. In this video, we will be studying data and how to interpret and analyze different types of data. Data is categorized into two main types, qualitative data and quantitative data. First, let's look at qualitative data. Qualitative data is data that can be observed and recorded. Let me give you an example to help you better understand this. So, suppose we have 300 cars, out of which 210 cars are good, 55 have slight defects, and the rest 35 are defective. As statisticians, the first thing we would do with this data is tabulate it. Tabulating data makes it easier for us to look and observe this data. Since now we know that this data is out of 300, we can use proportions to generate a simple pie chart. So to calculate proportion, we divide the frequency by the total number. Now we have the proportions. As you remember from GCSE, if we have proportions, we can multiply it by 360 degrees to get an angle of the pie chart. Then we can plot a basic pie chart using this data like this. However, with this data, we can even draw a bar chart. Which graph you choose to use will depend on the situation and how you want to present your data. So let's say you're on a stage and you want to present your data in a way that conveys your point precisely without presenting too much information or making it too complicated for the reader. Then you would use a pie chart. Pie chart shows the data, but it makes it unclear regarding the values, but it does show the overall trends in data. Whereas bar chart will give you more accurate numbers which can be used to stimulate discussions and conversations. Qualitative data is data that is categorical. It means the data isn't measured with hard numbers. Okay, coming back to pie charts, it is important to remember that the area of pie charts can indicate about the sample size, as area is directly proportional to population size. Note it's area, not radius. If you want to relate it to radius, you would say radius squared is directly proportional to population size. Let's try and make this clear through an example. An advertising campaign to promote electric showers consists of a mail shot, which includes prepaid postcard requesting further details. Prospective customers who return the postcards when contacted by one of the 5 sales staff: Gideon, Magnus, Gemma, Pandora, Murvet. The pie chart below represents the number of potential customers contacted and the number of sales completed during a 1-month period. The total number of potential customers contacted is 1,100. Find approximately the total number of sales completed. Okay, feel free to pause the video and have a go. To do this question, I would use ratios, since we know that the area is directly proportional to the population size. I know that 2 square pi would be proportional to 11,100, and since we know that the area of the smaller one would be 1 square pi, we can clearly see that dividing this by 4 will give us a solution. So dividing 1100 by 4 will give us 275. This is a solution. Okay, now here is how the textbook approaches this question. Anyways, have a go at part B of this question, which asks you to describe the main features of the graph revealed by the pie chart. Remember, you only need to comment on the obvious differences. So for example, if you look carefully, you can see that Gideon has made slightly more sales than Gemma, but this is so small that it is insignificant and it does not require a comment. Don't mention this in your answer as it's a waste of time. Now pause the video and have a go. Okay, here is my solution. Pandora has contacted most of the customers but completed the least sales. Merved has contacted the fewest customers but has made similar number of sales as Gemma, Gideon, and Magnus. Similarly, have a go at part C of the question. The manager wishes to compare the sales staff according to the number of sales completed. What type of diagram would you recommend so that this comparison could be made easily? Pause the video and have a go. To answer this question, we need to think about what type of data we are dealing with. In this case, we are dealing with qualitative data, so the best would be to use a bar chart, or a pictograph. This is all you need to know about qualitative data. So now we'll be progressing on to quantitative data. Quantitative data can be further categorized into two types, discrete and continuous. Let's look at discrete data first. Discrete quantitative data is data where values can only take a certain values. So for example, we could say shoe sizes, number of coins people have, etc. In shoe sizes, they can take any values, but they're restricted to certain values. So your shoe size could be 5 or 6, 7, 8, whatever. But it cannot be 5.2, 5.3, and so on. Similarly, you cannot have a 0.5 of a coin, so it is restrictive. This is discrete data. Dice rolls also is another form of discrete data. So, suppose I roll a dice, a six-sided fair dice, 100 times, and then record its value as shown below. I did this in order to test if my dice was actually fair or if it was biased. So the first thing when we look at this data, one would say that maybe looking at the first five, one is biased towards one or biased towards sixes, fours, and so on. But it is not really accurate. To make this data more accurate and easier to interpret, we would tabulate the data first. Tabulating the data makes it easier to look at and better understand this data. Although this data is good, but it's sometimes clearer and better to look at look at this data in a visual manner. So let's draw this onto a graph. The best way to look at this data is as a line diagram plotting frequencies. This makes it very easy to visualize and interpret and compare data. Discrete quantitative data can be best illustrated with a line diagram. A line diagram is essentially a bar chart shown like this, but a thin line is used to represent the data rather than bars. So here is an example of a line diagram from the textbook. Next, we will look at quantitative data. Quantitative data is continuous, so it can have a large range of values. A good example of this type of data is heights of people in a classroom anywhere. Furthermore, continuous quantitative data can be best illustrated as histograms. Okay, time for an example. Suppose you're given this data and asked to illustrate this data. How would you do this? Feel free to pause the video and think about it. Also, just so you are aware, in the exam, you will not be given data like this. Rather, it will be given like this, where you won't see the end boundaries, as they're supposed to be inferred by the student. So, first thing you would do with this data is, because you know that this data is continuous, the best way to illustrate this data is to use a histogram. To draw a histogram, the first thing we do is we would need to find class width. Once we found the class widths, we can then calculate frequency density using what we learned at GCSE. And after finding the frequency density, it's really easy to plot a histogram. However, you might ask, why can we not use a cumulative frequency diagram, cumulative frequency graph? Cumulative frequency graph can be used. However, this data is difficult to interpret for this situation. Now let's do another example question to make the use of cumulative frequency that makes the use of cumulative frequency graphs. So here is an example dataset which presents the weights of sample of expired blood donations. So the first thing we would do with this data is calculate cumulative frequencies, and then we would draw a basic graph. In this graph, you can see the cumulative curve. Additionally, I have also marked the median, the lower and upper quartiles. We may estimate the median by reading from the horizontal axis the value corresponding to n plus 1 divided by 2, where n is the sample size, and the lower and the upper quartiles are estimated by reading the values corresponding to n plus 1 divided by 2 and 3n plus 1 divided by 4 respectively. Note, you may however remove the plus 1 as long as you're dealing with large values of n. Questions on this section of the syllabus will be based on a table of the secondary data or on a real application of statistics. There is no specific techniques to learn, although you may require additional knowledge of topics. So let's do an exam style example question. Can't say my words. Pause the video and feel free to have a go. I will be putting up the solution in a second. Okay, since this data is quite big and I want to show the data while we go through the solutions, I will be taking down the questions so you won't be able to see them. So feel free to take a screenshot of this so you can refer to it while we go through the solution. Okay, here is the solution. The first question, part A, asks us, what were the London Underground receipt for the season tickets in 1997 to 1998? The first thing we would do is search for 1997 and 1998. Once we found 1997 to 1998, we would look for season tickets, which is over here. Thus, we get solution 389. But however, we cannot write just 389 because we are given a unit of 389 million over here. We must mention the units or it can be marked as incorrect. The second question, what were the average receipts per passenger kilometer in 1988 to 1989 and 1998 to 1999? This question technically has two parts. So let's first look at 1988 to 1989. The first thing we would do is we would look for the total passenger miles in 1989 and 88 to 89, which is this year, and the total passenger kilometers is this. Remember, units. However, since we are working majorly in millions, you can't ignore units in this situation. However, in your final solution, you must put about units. Once we found the total passenger kilometers, we can find the average received cost, which would be the seasonal tickets. Sorry, not seasonal tickets. Yeah, passenger total. Sorry, my bad. Which is 432 million again. Dividing 432 million by 6,292 million will give us our solution, which is 0.1455, which is 14.55p. In an exam, if you're dealing with larger numbers where you're dealing with them more in pounds, you can't ignore the last two because these do not really count. Just make sure you round them up. Similarly, do the same thing for 1998 to 1998 to Okay, for the next question, part C, what is average cost of a journey for the passenger using ordinary, i.e. not season ticket, not season tickets in 1988 and 1999? We would do the similar thing for this, but we would just use ordinary over here and ordinary from here. We would use this ordinary. Okay, part D. Comment on your results of part C, given that United Kingdom retail price is 110.3 in December 1988 and 164.4 in 1998. To do this, we would calculate. We would look at what we are looking at retail price index, and we can easily the best thing to comment on this would be the increase. So we would calculate the increase like this as shown here, and we would just mention this, and that's it. Okay, thank you for watching this video. I'm currently still working on building resources like these example questions we did. I will be sharing them as soon as they're ready. Please do consider subscribing and liking the video.